the first elephant in the room, I'm obviously a vested interest from the timber industry. The reason I'm doing the presentation is that it involved a bit of an understanding of timber products, codes and regulations, and really the cost plan information was just expression of the outcome, and so to be able to give a broad overview of everything, I'm in the chair. As I said before, the cost plans were developed from the RICS in the first place, and amended with updated information. The first one is the portal frame and comparison, and just a little bit about the parameters for it. The assumptions used was a building classification as a 7B, a wholesale distribution shed. We decided back in 2014 to locate these in outer Sydney suburb, and it had a building height of 5 metres and 1 storey, and building area of 32 metre span by 40 metre length as being a representative for 1,200 metre square GFA. This is just a plan view of it and a section through a timber portal. So fire resistance, it was a type C building, so there was no fire resistance requirements. The assumption was made it was greater than 3 metres away from the boundary. Also no acoustic requirements. Structural parameters, it was a type wind speed was a region A, terrain category 2 exposure, and it was topography model below said as 1, and foundations were reactive clay soil. So this was the conditions that were applied to both design. 3 designs were considered. Timber solution 1 had a 6.7 metres portal spacing. Timber solution 2 was 10 metres portal spacing, and the steel option was 8 metre portal spacing. And this was decided by the designers, original designers, and the project, and why the difference in the timber, not to bias the result to favour one material, but to was a test to find the best result, and part of that did uncover some lessons learned from the exercise. So the design, steel design, originally was carried out by Arrow. However, a revision was undertaken by TTW to optimise the design, and that was just to make it more efficient. We wanted to make sure that we weren't just comparing an efficient timber design against an inefficient steel one. We did go to and have it redesigned, so it was the most efficient steel design that we could find. Timber design was designed with assistance from Meyer Timber, option 1, and option 2 was designed by Carlisle Harvey's software. So onto the first solution. This is a 6 metre portal spacings, and just a little bit about it. And the first thing you notice is a few more portal frames than you would expect for the wider bay solutions. So it used as its main portal frame a 1,220 millimetre by 35 millimetre LVL 13 block bonded LVL. It used a smaller section, obviously, for the end bay portal, and 800 millimetres, again using block bonded LVL, and girts will end mullions at 463. The rafters were similar sized LVL, and I will explain a bit further why these particular sizes were used. And the purlins were just a standard 300 by 45 LVL 13, similar for the girts. Fly bracing is standard LVL again, and bracing was just 24 millimeter diameter galvanized rod, fairly typical for that application. All elements are termite treated H2S. That is a glue line treatment in the LVL. So a little bit about block bonded LVL. In this case, this was made up of 3 billets of LVL. They are 1,220 millimeters wide, which is the width of the billets, and they were block bonded in 45 millimeters thick, and 3 of the billets were block bonded to form the beam. This is just an LVL press and how it's made. This is Wes Beams press in Western Australia. So it's just veneers of pine with an adhesive pressed together on a very high load. That forms your LVL. And as you can see, this is the output of from the press, and this is a billet of LVL. So this is how it normally forms. So these big sheets of LVL is being utilised as a design. So one of those sheets, which is in this case for this design, is 1,220 millimeters wide, and 3 of these sheets were bonded together to form the rafter, portal rafters. So in this case, it's a manufacturer with this size thing, and you can just see that when you do this, you want to be able to use common sizes. So the 400, 390 millimeters are actually available from wholesalers, and the other sizes are explicit to the design. But you note the 800 has been chosen because that allows a 400 millimeter section to be chopped out from the billet. So this is important, and I'll be emphasising this right throughout the talk, is that using commonly available sizes does lead to savings and costs. The connectors used in this case was the Quick Connect, a system which was developed by the Structural Timber Innovation Company and supported by Forestman Products Australia, and that uses a sleeve which is screwed at an angle to the grain into the rafter and the column, and a steel rod is placed within the sleeves that is used to transfer the load. It is an efficient moment connector. As you can see, it's giving you tension value is quite high, and WoodSolutions does have a design guide, which was originally developed by the Structural Timber Innovation Company. It was available as Design Guide 33. So if you wish to know any more about this connector, please go and have a review that design guide. So again, this is just a plan view of this. So it's a plan view of the second option, which is a 10-meter spacing. So the first thing you notice is that there's less portal frames. In this solution, it used a 1 meter and 50 by 105 LVL 16. Again, it's a product that is from an LVL supplier, and by millions of 400, very similar to what we saw before. The rafter was using the same size LVL 16 with the 800 and 400 size LVL as the end bay rafters. Purlins, in this case, we're using a 400 deep by 90 I-beam or I-joist, as it's commonly called, and girts were using what we previously used in design 1, just LVL 13. Again, the same type of bracing was used, as well as fly bracing. All the timber elements were termite treated to H2S. So just note that this is manufactured from the 1 LVL billets, and that's a key point, which I'll keep emphasising, is that you want to be able to keep the cost of fabrication down by using standard sizes. So just a visual description of this, so the purlins and girts and portal frame as shown in the diagram. So the moment connector in this case is different. What we're using is a nailed or screwed LVL gusset, quite an efficient way of moment connection, and this is obviously screwed to each element, and it's a common way of creating a moment connector in the timber portal frame. So the cost information in this one was derived from the Building Cost Index, and that for 2020, and this was used whenever we could. So it was put together by Australian Surveyors Institution, and it's a very good book to go and get pricing for it. It has its limitations, but wherever possible, the costings for this review was derived from this book. The cost information was not available; it was found from Marketplace. So Meyer Timbers was very helpful in obtaining realistic timber prices from suppliers and fabricators. The steel price was initially used from the Building Cost Index, but it was cross-checked with several contractors to ensure that the price was representative of the marketplace. And again, we were very sensitive to make sure that the costings was realistic, not something which is biased towards a timber outcome. So whenever we could, we erred on conservatism and used what was considered to be the most relevant information. Many of the materials used for this solutions are the same within both designs, so we haven't really included those costs, such as concrete slab, claddings, fit outs, MEPs, and etc. So they assume that they've been ignored in the cost plan, because anybody can go and get those themselves, and didn't matter on the design. Program time was also assumed to be the same for all design. That's probably not the case, but for the purpose of the cost exercise, that was assumed, and the equipment used and cranes and whatever was used was also assumed to be the same. Again, that was probably a conservatism built into the cost plan, but it was again trying not to bias one result over another. The preliminary costs and margins were also ignored, and the cost, in fact, when it comes down to it, what we're doing is effectively doing a cost comparison of superstructure, and that was basically what was looked in the study. So just a little bit of comparison between the two timber options. So if you look at, really, it becomes the portal frames, and firstly there's a high number of portal frames for the smaller spacing, and also the 6 metre spacing also use block bonded, which is a fabricated element, while the 10 metre portal spacing system just uses elements which are straight out of the factory. The rest of the items are pretty much lined up with each other, except for the purlins, which were solid LVL for the 6 metre 0.7 and eye joists for the 10 metre portal spacing. The steel solution used an 8 metre portal spacing. Again, that was selected by the designer, and it was using it as a 530 UB82 and in bays 460. Pretty standard stuff for design. The purlins were 200 Z24s, and similarly for the girts, one wire bridging was used, and columns 50 UBs, and fly bracing, the 3 per rafter. Pretty standard, and the same technique for bracing was used, being the galvanized rod. So pretty stock standard steel portal, all zinc silica treated, and the moment connector was your standard bolted knee connection arrangement, and standard for all steel portal frames. This is a plan of this, and you can see it has a different spacing arrangement compared to the timber one. So that's effectively the solutions in timber and steel. So now on to the cost plan outcomes. Now, and just to remind that the full details of these cost plans are available in the WoodSolutions guide, which is discussion which are available. So if you want to know more detail, please just go to the WoodSolutions guide. So a comparison between the superstructure, that's basically the footings, and you can expect because there's more, you can expect the difference between the timber one, because there's less portal frames for the 10 metre one. The steel portal was a little bit more expensive than expected, but still pretty much within expectations. The columns, in this case, the timber portal 1, solution 1 is pretty similar to the steel portal frames, but the timber portal 2 columns were less, and you can just imagine they're using out of the factory type sizes as well as less of them. The roof, pretty much the same cost throughout, but we'll go into a bit more detail shortly about it. External walls, again, pretty much the same. The purlin costs or girt costs of the walls were in the timber portal option 2 was a little bit cheaper. So the total meant that the timber portal at the 10 metre base spacing ended up being cheaper, while the timber portal solution 1 and the steel solution were pretty much the line ball with each other. The difference between those, not enough to point out that there's a significant difference, but the option, so the timber portal solution option number 2 was cheaper. So what caused that? $59,000 cheaper, 18.5% cheaper, less than the steel solution, and the saving of the timber building was found in the footings. Obviously, little bit cheaper because there's less of them. Makes sense. Columns were substantially cheaper. The external wall was a little bit cheaper. But the observations from this is that the sorry, I said that the actual steel portals were cheaper. The actual steel portals were actually cheaper than the timber portal option. So the option 2, which had less portal frames, meant that option was going to be cheaper. So there's a bit of a trick for that. Is it's a bit of a counterintuitive that you have less. You would expect timber wouldn't span as far, and you would have the closest centres. But in reality, for an efficient design and timber portal frame options, you space them far apart, and that's basically the other aspect to all this. That the I-beam purlins were cheaper than the steel purlins, so that kind of makes sense. If you have more, you can get away with a more expensive I-joist and I-beam arrangement, and space out the frames, and then we'll end up with a cheaper option. They point to the I-joist as one of the cheapest ways of providing a rafter, girt in a sense that is possible. So it's even if you were looking at a steel portal frame, they're not even suggest this as a halfway measure that the I-joist purlins would be a suitable thing. In addition to that, I would also suggest that the floor, parallel corded trusses are also in a similar vein, cheaper. Solid LVL is more expensive. It has advantages in that if you're looking for a system that doesn't have any bird perching, then that would be an ideal solution, because there's no birds will be able to sit on the edge of the I-joist or the C-section or truss. Further observation, the timber option utilised off-the-shelf components that did not require additional fabrication. So this is a picture of Meyer timbers in Sydney's just iRobot CNC machine, and they can cut that to length and at an angle and provide some rudimentary fabrication, and that's what you need. So that's what the trick is. It's when something needs a bit more fabrication, and that's when the costs blow out. So if you can design your structure to utilise off-the-shelf type or out of the warehouse type of elements, then that's where the cost savings come from. Option 1 was the fabricated element, and in effect it was doubling the cost of the standard wholesale item. So you're not getting and that's pretty normal if it's same as the steel one. If you have to remanufacture it and apply some fabrication to it, then it's going to increase the cost. So if you were able to use steel, then just pull them out of the wholesaler's yard, then the similar savings also occurring. But in the timber option, it's much easier because of the ability of cutting and putting holes into the timber. And timber is quite often done these days, and there's many suppliers that are able to do that for you. So that's really the trick to what causes the difference, is that we're using products which are coming out of the wholesaler's yard with minor additional fabrication on it, compared to something which requires a lot of fabrication. And that's clearly the observation to learn, and also that the I-joists or floor truss types or parallel cord trusses are an ideal way of purlins, are a very cheap option to spanning and supporting roof and wall elements. So that's another observation. Further savings could be possible. Again, though, as said before, they were ignored. The timber portal frame could be built on the ground, because this inherent stiffness of the wood has meant that it could be built in one bay with type arrangements. So it's saving on the working in height arrangement. That's something that I recommended people if they're looking at doing a timber portal frame and investigate a bit further. Because it's a viable option for it and quite a common way of doing it. And completing the discussion on that, mentioned Meyer timbers a little bit. Not meant to be favouring them at all, but the inspiration for this talk really came from their efforts in a shed out in Penrith, in Western Sydney. And in this case, this shed was 15-metre bay spacings, and it was a discussion for a previous WoodSolutions webinar which was held in late January. So if you want to know more about that particular project, go back to the webinars series for 28th of January, and you'll be able to find that information. So that's looking at that to get the most cost effective. It's kind of counterintuitive. You widen the base spacings with timber, which is kind of like is opposite what you're thinking. So I recommend to people to have a look at timber portal frames. Be mindful of those lessons learned about keeping it away from the fabricator as much as you can by using stock out of the warehouse type items is where you'll get the savings. If you do heavily fabricate, then you're more than likely it's going to be pretty much line ball with a steel solution. So that brings it to the end for our first one. We would just a quick look at the questions. Okay, so I'm just going to answer these questions now. This first one was anonymous. Why are the timber portal columns rafters smaller for the 10-metre bay? The smaller than the rafter for the 10-metre bay compared to 6.7-metre bay. There's different properties. An LVL 16 was used for the 10-metre bay one, which had obviously having a higher MOE value, and that was able to get around the difference in material. Also, when the ability of using products which are 45 wide, it wasn't able to get the most efficient out of it because you're using standard thicknesses of thickness of LVL for the block bonded material. So it may not necessarily need 3 lots of 45, but because that was the available sheets for stability and gluing, it ended up being that width. John Strauss, did you compare the volume of timber used in solution 1 to 2? So does the solution 2 use less timber? That's the short answer is yes, that was done. It's not reported in the guide. Quite obviously the eye joist and the less rafters, so port frames has caused that. So the total volume of wood in the 10-metre spacing is a more efficient design. So the eye joist particularly are going to reduce the amount of wood being used considerably. Because in reality, it's the purlins and girts which make up the volume of material being used in the building. It's not really the rafters, portal frames, and that's why that changes occur in pricing. And Kevin Nutella, what is the fire rating FRLs of the timber columns and rafters? Well, this is a 1-story building. There is no fire resistance for this one, but as you probably can guess, there is inherited fire resistance for the timber, but that wasn't a part of the design because it was a single-story building, type C, away from the boundaries, so there wasn't any fire resistance at all required. And also roofs and structures in the NCC don't require any fire resistance. So thank you for those questions, and we'll move on to the next presentation. So two-story is actually assisted living building was a next case study, and the building parameters of that. It was again located in our Sydney suburb, and it was a 2-story building, 6 metres on the side of eaves, the gross floor area 1681, and the building classification was a 9C. So that, just a hint to anybody, the 9C was one of the CPD questions. And it was just a standard assisted living arrangement. In this case, we actually use a fictitious design, and you can tell that because the Smart Aleck designer used staff name as the street names just to give it some reality. But that you can just see from there is just a number of SOUs, or so unit rooms with an ensuite to them. There was living areas and dining areas, and they're pretty much just a repeat above each other with the usual reception and foyer arrangements that you expect from these buildings. So it's upper story, and you can see pretty much the same layout as a lower story building. So pretty stock standard, not meant to be anything extraordinary, just a fairly straight design. Again, we asked a building designer just to do what they would normally do and have no consideration of the material being used. It's an elevation view of it, and section view through it. So fire resistance, and this is a bit of a trick to all this. If anybody's dealt with 9C buildings, you'll know there is something there. So NCA has options available for fire design with Class 9C buildings. So I'll explain a bit more shortly. And for New South Wales a variation, and these requirements will be used in the design of this building. So be wary that your state may actually have some requirements differently to what the NCC. So in this case, we have used the New South Wales variations for the design. And we'll go into more detail just now. So the NCC has a number of distinct solutions for in Class 9C buildings. These methods are applicable for different rise and stories and type of or classification of building it's meant to be. And so type A, B, or C. And the WoodSolution is a term. We have a solution, what we call BCA specification C 1.1 method, fire protected timber method, which is what we use for mid-rise type buildings. And the third is a BCA provision C 2.5 Class 9C building solution. A bit complex because there is different fire resistant requirements for each option, and it's up to you to decide which method you want to use. To try to demystify all of this, there's a WoodSolutions guide which is just recently updated, and it's available for download, and it goes through the various designs for that. So there's a bit of effort trying to work out to explain where you use what and what advantages you have for each. And so bear with me. It's not when you're talking about building regulations, as you know, it's not quite easy, but there is. It's like you need about 3 or 4 computer screens open to read different parts of the NCC at the same time to understand where they have it. So the BCA specification C 1.1 method, that's your standard fire resistance requirements. So that's what you'd use normal for anything. So we're just using the specification C 1.1 provisions and designing the building accordingly. And there's some options there for you. This method is recommended for low rise type C buildings because when you get above 2 stories into 3 stories and above, you're out. It doesn't apply because there's constraints on materials, and you're into fire protected timber land. So the type C construction, particularly for 2-story buildings, and you'll find this is one of the options that we looked at. The other method is fire protected timber. We all heard about that. It's the method is using the specification C 1.1. But it's a fire protected timber requirements and replacement of the non-combustibility building elements with fire protected timber. So that's used and can be used up for structured timber encapsulated in plasterboard and things like that. And it's applicable for type classifications of types of buildings as A, B, and C, up to a rise of 25 metres in height. So that's another way of doing it, but you'll find that it involves more fire resistance protection, and it probably wouldn't be a suitable suggestion, most economical for timber. So the BCA provision C 2.5 Class 9C buildings, and the first thing to know, this is meant to use specific provisions within the NCC for Class 9C buildings, and there's one specific requirement requiring all floors to be 60-60-60, irrespective of the pathway used. And it's just a note, within provision clauses, that there are fire resistance requirements that are optional to the traditional thing. But there is no limit on the type of construction or rise and story, but how there's implied limits on the timber use. Just the first thing to realise is that there is specific solutions within the provisions, and a provision is hierarchy in the NCC over a specification. So think of a specification in the NCC as actually like a standard. It's a cookbook approach of solutions. The provision is actually a requirement, and so they are hierarchy. So if there's a requirement within the provision, that takes precedence over the requirements within the specification C 1.1. So it has additional requirements of smoke-proof walls with area limitations, minimum fire resistance for 60 minutes for floors, and optional internal wall solutions. And this is the third option. What we're talking about is that if you use that option, you can utilise a different solution. So just remember, the specific provisions take precedence over specifications. And just have a look at the words within the NCC. So this is the relevant section, and you find here, a fire compartment must be separated from the remainder of the building by firewalls, and notwithstanding C 2.7, which is on firewalls, and specification C1.1, which is your standard fire resistance and solution. Floors with an FRL, notwithstanding that, ignoring those two, floors have an FRL not less than 60, 60, 60. The optional bit is internal walls, other than those bounding lifts and stair shafts, which is a fall back to specification C1.1, and supported by floors in accordance with the talked about before, need not comply with specification C1.1 if they have an FRL not less than 60 dash. So that is a saving on the walls if you wish, and you can take it up if you wish, but it's saying that it's an option to the specification C1.1, but it's only when it says need not comply, it doesn't mean it must not comply. It means that you have a choice there. And that's why we have the third option. Confusing, isn't it? It's, you know, I've looked at this many a times, and must admit it always it involves me rereading it a few times before you get hold of it. So just remind you that WoodSolutions guide does attempt to explain these things. It's not easy, and we recommend that you have a look at it, and you can, you know, kind of like explain through all this. But as we said to start, we have a variation to deal with for New South Wales. So New South Wales has its own set of requirements that which have varied the NCC's provision C2.5. So again, remembering provisions have a hierarchy over the specification. In this case, for type A, Bs and C buildings, non-living walls between SOUs, the public must be aligned with each side with 30mm standard grade plasterboard material with at least equivalent fire resistance. And cavity insulation is to be non-combustible, makes sense. And for type C construction, load-bearing walls and to public corridors, comply with specification C1.1. In this case, there's no fire resistance requirement. However, specification clause, sorry, C1.1 clause 2.2, fire protection of support of another part, requires that if something supports a fire rate element, in this case, remember we had a requirement that all the floors need to be 60 minutes, then what supports the floors requires to be also fire rated. So if the design was that the walls weren't load bearing, then it only requires a 30mm standard grade plasterboard as the wall linings. But if the walls are supporting the floor, then they require to be 60 minutes. And so that gives you some requirements for it, which takes a little bit of reading within the NCC to understand. That determine our fire resistance use in this building. So in this case we allowed the NCC provision for a rise of 2-story building, which is a type C construction, if a sprinkler is used throughout. And guess what? 9Cs are required to have sprinklers throughout. So we can use that provision to define a 2-story class 9C building as a type C construction. As a structure is assumed to be located in New South Wales, and the convention requirements were used, and the same fire resistance assumptions were used in both applied timber and the steel design. Just a summary of the assumed fire design. Fire resistance sprinklers installed, type C construction, 2-story walls. For the non-load bearing walls, 30mm plasterboard was used. That's effectively a top story design. For the load bearing, not a 60-minute system was used, and the floors are using 60 minutes as well. Acoustics, there is, just a note, there's a lesser requirements for assisted living, 9Cs, and RW45, as long as there's no mechanical link between peripheries. So that allows a lesser system to be used for acoustic requirements. So the two options we looked at was lightweight timber frame and lightweight steel frame, making sense. And we look at it, all other aspects of the building were identical, you know, foundations, concrete slabs, surface coverings of walls, and MEPs, and so on. So we look at particularly at the system. So we have a steel frame versus timber frame, and you find that they're pretty much the same. So really what's differing is the frame, except for the ground floor load, non-load bearing. Sorry, that was meant to be load bearing. And we find that we've used staggered studs for the timber frames and a noise stud, single stud arrangement for the steel frame. All these systems comply with their requirements for fire resistance and acoustics. The floors, pretty much the same again. Just no pictures with insulation in it steel frame, but the only real difference between the two is that I-joists were used for the timber frame and C-sections were used for the steel frame. The rest of the systems are pretty much identical to each other and had an identical acoustic performance between all of them. So really making it easier to see where the differences are. So there's beams, 4 beams, which and there's a few of them used within the design. They were actually incorporated within the fire resistant construction of the floors, so there's no additional fire resistance for them. However, the columns for the timber one, the size of the columns was enough capacity of the timber char that meant they weren't additionally sized because of it. However, the steel one was actually fire protected with plasterboard. So to the cost plan, and we find that again we use the bill of quantities from surveyors as determining the rates to be applied, and where there was no information constantly available, a price from the market was used. So the cost of information, many other materials, and as we said before in the portal frame solutions were the same, so we did not include them into it. So MEPs, floor slabs, cladding, etc. Program time was assumed the construction program at the time equipment we used was the same. Preliminary costs and margins were also ignored. Cost comparison effectively the superstructure cost comparison. So to the results, and we find that for the columns there's a slight difference in favour of the timber, and that's basically because the timber didn't require any additional fire protection to it. It was able to use the char resistance of it, while it still required it. Upper floors is where there was considerably difference, and again it was in favour in timber, and I'll talk more about that shortly. The roof were identical. Ceilings were identical because it was the same as the same plasterboard sizing was used. The external walls were a little bit different in favour of the steel solution, and also the interior walls was different in favour of the steel solution. I'll talk more about why is that the case. So the total solution, in effect, the timber just came out slightly ahead of it, but pretty similar in cost. So the timber solution showed savings of $22,000, 2.4%, lower than the steel framing solution. Savings in the timber building were found in the floor, so $31,000. And effectively, that's again those I-joists. They're a bit of a wonder product, but I'd also remember that floor trusses can be used. The column was also cheap because of what I just said. No additional lining required. The additional costs were in external walls, and when we looked at it, was the BCI is the building cost index. It had no load-bearing steel frame cost systems. It just had basically the partition costs. So doing the costings, effectively using just a non-load-bearing partition costs, which a question if that is actually applicable. And shortly I'll talk about an actual market cost was found between the two. And the internal walls for the timber option, we found that they were using stagger stud. And in fact, there was studs at 300 centres and some more material. So maybe a resilient mounted wall system, which is at 600 centres, could be a cheaper option for the timber one. In addition, there wasn't actually a staggered stud price within the cost index. How that was obtained was using the single stud rate and knowing the difference between single stud rate and stagger stud rate from the marketplace. The BCI rate was increased accordingly to reflect the cost difference between staggered studs and the rates which were in the BCI. But we did find that the costings for the timber were a bit beyond the market. So price. So what we did was we got a price from the market. So real quotes were obtained. Done at arm's length. So it wasn't. So no one knew who was actually asking for the price, and it was just for the frame material only. The steel price was $231, and the timber price $193. So they kind of like pointed to there is an option. Timber can be cheaper, but it's the use of those floor joists was where it was a difference. So a bit of saving in the cost plan. So in conclusion, that I-joists and lightly for floor trusses can be substantially cheaper than steel frame floor. We see that in steel framed houses. They use I-joists for that certification, so that probably bears out. And the Construction Institute of Quantity Surveyors building cost index price for timber frame did not meet market rates. They're a little bit agricultural in their rates. They could deal with a bit of threshening up because they do not really match what the rates are from the marketplace. And it's just using the market rates for both steel and timber if you're going to do a price comparison between these two for this building type. So next steps. So what we're doing. So each one of these cost plans in those books, there's company documentation explain what was used and why what. So again, those books guides are available from WoodSolutions website, and they were all updated in 2020 pricing. So please feel free to go and download and have a look at them. And there's assumptions as much as you can are explained wherever they can, because just like that story about 9C buildings and fire resistance, it's not an easy way through, which is a common thing for timber. There's bits and pieces of the NCC which you may never have seen before, but they are required or can lead to savings within timber options. So so that's in the guides we attempt to describe that. So the other so moving on, that's completes the cost. We're going to talk a little bit about timber shortage, but in planning for this, we found that the available time that we had was not enough. So it's the indicator such in this matter. But what we're going to do is this is such an important topic. It's been held over to be a dedicated future webinar. So just look out for this one, because it's not an easy discussion to have on what's caused the timber shortage or price increase. There is no real shortage, just a shortage of cheaper wood, which is what really the issue. But it needs to to give it serious attention. It couldn't be done in a couple of minutes, which was intended for this original presentation. So let's leave it over to another webinar in the near future. So thank you to the design professionals. There was a number of companies and people used to derive all this cost information from architects, engineers, and builders. So the appreciation is going out to all those people who assisted in developing this cost plan information. So questions. So I see we have 5 new questions. I'll address those. Okay. So Michael O'Connor, have you investigated the life expectancy comparison between timber construction and steel construction? I haven't directly, and that wasn't a part of this particular exercise, but there is very little difference between those two materials. They both are going to occur in interior environments, and the expectancy for both of these products are going to outlast the expected life of the building. So there's can't see any difference in that one. So there's the CPD questions. Okay, so just moving on into wrapping all this up, and we'll wrap up early because there's no other questions. Just a reminder that these WoodSolutions webinars are available from the WoodSolutions website. So this one will be uploaded shortly. You also will shortly get the certification of attendance, as well as the 3 CPD points. 3 CPD questions. So please download and keep in a safe place. The webinar survey also is attached to the form, so if you please, you've got time to fill out the survey, so that helps us identify what you want to hear. The next webinar is in 1 week's time, and this one is going to be on the Granville Park Stadium, and we have 2 presenters, being Ivana from Design World Partners and Nick from Northrop Engineers. And it's a great presentation. I've heard it just recently, and it's a great story, and it's a wonderful structure. Who would have thought they'd be using timber in a stadium building? So this one is a recently completed project in Granville, and it's a discussion for our next week's webinar. So please register for that. So also for anybody from Canberra, we are actually doing face-to-face seminars now. We had the first one in Sydney last week. We have our next one in Canberra on the 23rd of June. So please go to the events page on the WoodSolutions website and register for it. So it's going to be actually within the ANU's Mary Ray building, which is that pictured in the centre of that image, and so on the top floor. So we'll also get a discussion from builders on some of the aspect of the building by seeing it actually in person. So opportunity to attend, so please register for that, and face-to-face seminar, and also find fairly lengthy list of other topics being discussed. So that brings us to an end. We're about 5 minutes early for the webinar. Just checking to make sure there's no other questions. There seem to be any. So I'd like to say thank you for attending this week's webinar, and we'll see you at the next webinar, or in this case, seminar. So thank you again for your time, and look forward to seeing you again.